Hello students, welcome to my YouTube channel Data Shah. In this lecture, we'll be talking about the type 1 and the type 2 errors and the various definitions that you should know while doing the testing of hypothesis. So let us consider one example that you are going for a test for COVID-19 and you have certain mild symptoms. So the result, the reports of your test states that you don't have coronavirus, but actually you have coronavirus. On the other hand, when the reports says that you don't have coronavirus, but actually you have it, then in these cases it shows error. Now, how to deal with such kind of errors? In the last lecture, we have done null hypothesis and alternative hypothesis. So, if we have a hypothesis, null hypothesis, then either we will reject the null hypothesis or we accept. That means we fail to reject it because it is true, so we have to accept it. So, we fail to reject the null hypothesis. Now, if we are rejecting the hypothesis, what are the chances that actually H0 is false? If we are rejecting the hypothesis and H0 is false, then there would not be any error. But if H0 is true and we are rejecting it, then certainly it arise error. Similarly, if we accept our H0 and H0 is false, then again it will create an error. And if we accept the H0 and H0 is true, then obviously it will there will be no error and it would be our correct decision. So in this table, if we are rejecting the H0 and H0 is true, then obviously there is an error and it is known as type 1 error. If it's false and we are rejecting it, then our decision is correct, so there is no error. When H0 is true and we are accepting it, that means fail to reject means you accept H0. So there is no error because your decision is correct. Whereas you accept your H0 but H0 is false, then this is known as type 2 error. So what we can say that the error of rejecting the H0 when H0 is true is called the type 1 error, and it is also denoted by it is also known as alpha error. The error of accepting H0 when H0 is false, then it is known as type 2 error and it is also known as beta error. So type 1 error is also known as false positive. So let me write it with another color pen. False positive. And the type 2 error is also known as false negative. Whereas the other ones, this is known as true positive and this is true negative. So true positive means that we are accepting H0 and H0 is true. So both are, there is no error. So it's a good thing. And true negative means that you are rejecting H0 and H0 is false. So your decision is correct and H0 is false in this case. So it's showing true negative. So this is how we can form this table, and this is actually the decision table for the hypothesis testing. This is the decision table that will help us for the hypothesis testing. So we could say that I could define my alpha error and beta error similarly like this. The alpha error would be the probability that we reject H0 when H0 is true, and beta error would be the probability that you accept H0 when it is false. So this is how we can define alpha error and beta error. Now we'll be defining certain more terms that is required for the hypothesis testing, which is the acceptance region, rejection region, and the critical values. So let me draw the diagram. Here this is our the null hypothesis, mu is equal to mu naught, and we have this regions. So this is the region where we are rejecting our null hypothesis, and this is the region where we are accepting our. So this is denoted as this is alpha error here, because I am reject H naught. So the red portion where you could see, this is you are rejecting your H naught. So this is the rejection region, and this region where we can accept our H naught is called the acceptance region. So let me just define acceptance region is the region which consists of values which appear to be consistent with H naught, or we can say we are accepting our H naught. Whereas the rejection region, it is also known as a critical region. So it's the region where the H naught is rejected, is the region where H naught is rejected. Now the critical values are those values which separates the critical region and the acceptance region. So are those values which separates the acceptance region from the critical region. So the critical values would be defined these are the critical values. So it is defined by minus Z alpha by 2 and Z alpha by 2. So these are the critical values which separates the acceptance regions from the rejection region. So whenever we are doing the hypothesis testing, we can always create such kind of a diagram where we could find out the rejection and the acceptance region, and it is very easy for us to formulate our hypothesis and then finally the answer. So the alpha and beta according to the region, if we define, would be given if W, if I consider W to be my rejection region, and W dash, this is W dash, the whole area, it's the complement of W, it becomes my acceptance region. Then what would be my definitions for the alpha error, beta error? So alpha error is the probability of the type 1 error which is reject H naught when H naught is true. That means the X belongs to W rejection region whenever H naught is true. Whereas beta error is the probability of the type 2 error, which states accept H naught when H naught is false, which also we can write it as X belongs to W complement when H naught is false. H naught is false means that H1 is true. So that's obvious. And also we define power of the test. The power of the test is defined as 1 minus beta. So basically it is the probability when you are rejecting your H naught. Let me just first write its definition. Power of a test is the probability of rejecting H naught when H1 is true. So power of a test is defined as 1 minus beta, and now we'll be doing certain questions related to this type 1 and type 2 errors. So a noun contains either 3 red and 4 black, or 4 red and 3 black balls. It's missing, this should be 4. 3 balls are drawn at random and from the urn, and on the basis of the colors the inner object of the urn is decided. The null hypothesis H naught is that the urn contains 3 red and 4 black balls. If H naught is accepted in all the cases other than drawing of all the red balls from the urn, then find the value of the errors. So here we could easily identify that H naught is given to us. So H naught is that there is 3 red and 4 black balls in the urn. H1 would be, if this is an urn contains either 3 red and 4 black balls, or 4 red and 3 black balls. So the alternative hypothesis would be the other one, 4 red and 3 black balls. Now it states that what is our we have to find out the type 1 and the type 2 errors. For that we must know what is the critical region that we have, the acceptance region, the rejection region. Now H naught is accepted. That means the acceptance region that we are talking about when the drawings of all the red balls, in all the cases other than the drawing of all the red balls, that means all the 3 balls are not red. It could be either 0 red, 1 red, 2 red, but all should not be red. So let us first define the X, that is the number of red balls amongst the 3 balls, because we are drawing 3 balls at random from the urn. So now X could either be 0, 1, 2 or 3, because we are talking about the hypothesis. So our critical region and the acceptance region. So therefore W dash complement, I am defining it as X such that X is 0, 1 or 2, and this is X such that X is equal to 3. Now this is W complement is our rejection region or the critical region, and sorry, that's our acceptance region. and W is our rejection region or the critical region. So how would we find our alpha error and beta error? Alpha error is defined as we reject our H naught when H naught is given to be true. So this means that X belongs to W because here I have already explained that W is the rejection region. So we are rejecting, that means X is belonging to, this is capital X. Capital X belongs to W when H naught is true. So this would be P of X equal to 3 when H naught is true. Now when H naught is true, that means in the urn we are having 3 red and 4 black balls, and we are talking about the probability that X is equal to 3, that all the 3 balls that are selected from the urn are red balls. So it would be, the probability would be easy, 3C3 over 7C3, and we could calculate it, the value. So this would be 1 over so that's 6 over 35 into 6. So that's 1 over 35. That's our alpha error. Now beta error would be given by the probability that we accept H naught when H naught is false, that X belongs to W complement when H1 is true. So we could say that P of X would be 0, 1, 2 when H1 is true. So H1 is true means that we are talking about 4 red and 3 black balls. So in this we are saying either there is 0 red, 1 red or 2 red. In this case we could also find the probability of this by P of X equal to 3 when H1 is true. So that would be equal to 4C3 because there are 4 red balls in this case and 3 black balls, 7C3. So that would be equal to, we could calculate, and we will be calculating it in the similar manner as I have shown above. So it is 31 over 35. So this is how we can calculate the alpha error and the beta error in this question. We have another question. Let P be the probability that a coin will fall head in a single toss. In order to test the hypothesis, the null hypothesis is that H naught is P is equal to 0.5 against the alternative hypothesis that P is equal to 0.75. So the coin is tossed 5 times and H naught is rejected if more than 3 heads are obtained. So that means more than 3 means it would be 4 or 5. So that's the rejection part that we'll be finding out. So in the similar way that I have written in the last question, we'll be finding out the type 1, type 2 errors along with the power of the test. So here we are already given H naught and the alternative hypothesis, and let us define X to be the number of heads. So clearly X as we know is the binomial distribution, so it's 5p because n is 5. It is given to us, the coin is tossed 5 times. Now the probability, as we know, could be found using the probability mass function. So let us first define our critical region and the acceptance region. So W complement is our acceptance region, and W is our rejection or the critical region. So rejection region, as we know, is X must be greater than 3. So and acceptance would be that it is less than equal to 3. So that means less than equal to 3, we'll be considering it could be either 0, 1, 2, 3, and greater than 3 would be, here it could be 0, 1, 2, 3, and here in this case it would be 4 and 5. So let us now calculate alpha error and beta error. Alpha error would be X belonging to W when H0 is true. So that means P of X greater than 3 when our P is given as 0.5. So the probability would be P of X equal to 4, and when P is 0.5, plus P of X equal to 5 when P is 0.5. So just putting in the all the values in the probability mass function, we will get here 5C4, P is 0.5 raised to the power 4, 0.5 raised to the power 1. 5C5, 0.5 raised to the power 5 raised to the power 0. So clearly we could find here the value is coming out to be 3/16. Now what is beta error? Beta error is the probability of X belonging to W complement when H1 is true. So X less than equal to 3 when P is 0.75. So here we'll be talking about P of X equal to 0, X equal to 1, X equal to 2, as well as X equal to 3, given that P is 0.75. So now putting the values here, instead of this I can also calculate P1 minus P of X greater than 3. So it includes only 4 and 5. So I'll just erase this. So this is nothing but X greater than 3 when P is 0.75. So this is 1 minus P of X equal to 4, P of X equal to 5. So it's not similar as we have calculated above. It is different because here P is 0.75, above it is 0.5. So you need to calculate it again. 5C4, 0.75, 0.25 plus 5C5, 0.75, 0.25 per 0. So ultimately we are getting this as 47/128. Lastly, the power of a test is given by 1 minus beta. That's 1 minus 47/128, and that's coming out to be 81/128. So this is how we can calculate the alpha errors and the beta errors for the questions given. In the next lecture, we'll be talking about the p-values and how we could find out the p-values for the hypothesis testing.